So far, we have talked about capacity planning for products. We didn't mention it, but that was the case. You may be wondering how would capacity planning for service would be different? Well, service, as you remember from the first chapter, the introduction, has its own characteristics and differences with the product and manufacturing. So there are some concerns and some restriction that is specific to service. And that's going to be important impact our capacity planning. For example, service needs to be near customers. Customers need to have uh, convenience in accessing the service. This is not a concern for product. You can have your manufacturing in another country, even far from it, far from the customer and the market, and then the product can just be shipped to the retail store or the store close to customer, or the customer can even purchase the product online and it's going to be delivered to. This is not the case necessarily for service. For example, consider a customer who wants to get a haircut. The haircut salon or haircut barbershop, it has to be close to the customer. So convenience and proximity or proximity is actually one of the restriction or one of the characteristics of service. Another characteristics of service which is going to impact capacity planning is the inability to store services. This is not the case for product. You can actually manufacture as many as you want from a product and then store it or put it in inventory, and when you need it you're just gonna give it to the customer. But you cannot, this is just not possible, you cannot put in inventory or store service. How can you, for example, it doesn't even make sense, how can you store a haircut service, or how can you store um, a repair of a car, you know? So this is inheritance to the nature of service. You cannot store it. So because of this inability to store, you have to consider this when you do the capacity plan. Another concern and characteristics of service is the degree of demand volatility for a service, which is not really the case for the product and manufacturing. The volume and timing for demand, it can be actually more volatile for service than it is for the product and for manufacturing. Also, unlike the products which are generally standard and they have a standard processing time, service can actually be very individual based, and it can be different from customer to customer. So these these conditions and many other conditions would make the capacity planning for service different and more challenging than capacity planning for product and for manufacturing. One of the alternative that you might have not thought about it regarding expanding your capacity is actually, instead of expanding your capacity to be able to provide and supply to the market when the demand is at the peak, you can actually use some tactics to try to shift the demand from the peak or from the season to other time periods that the demand is not as high. These strategies, called demand management strategies, are used to offset capacity limitations and that are intended to achieve a closer match between supply and demand in other time periods. So these tactics can involve strategies such as pricing, promotions, discounts, and any other types of um, strategies that would entice the customer to purchase at other time periods or at your, for example, discount time period or promotion time period, rather than waiting and shopping in the high peak season, for example, Black Friday or um, the New Year's or Christmas or any other seasons that we have high demand in the market. Manufacturing in-house or outsourcing. Once the capacity requirements are determined, the organization must decide whether to produce a good or service itself, which is called in-house, or to outsource it to any other manufacturing or provider in any other type or region, or even out of states, overseas. But before they do that, there are some considerations and some concerns to be aware of and think about. For example, the available capacity that you have, the equipment, the skills, the time, if you want to manufacture in-house, you have to be careful about those. Also, the expertise to do a satisfactory job. Do the organization or the business, the third manufacturing company that you want to ship, you want to outsource your manufacturing to, do they have the expertise? And also, do they do a good job in quality? The quality consideration is also important, of course, and especially that you don't have um, any control over the process, because this is another company that do the manufacturing part. So you're gonna lose some direct control over them. And also the other factor that you need to think about is the nature of demand, whether it is steady or it's fluctuate a lot, the level of uncertainty in the demand market. That's also important to consider when you want to decide whether you want to manufacture in-house or outsource it. Besides those, generally it's cheaper in short term to outsource your manufacturing, but in long term you have to be careful whether it's long term is in your favor to do that. And also you have to consider other costs associated with outsourcing. For example, the transportation costs. But there is some fixed costs associated with the manufacturing in-house, because you have to expand your capacity. For example, you have to rent a facility or buy a facility and buy equipment and hire people. But you have to analyze, do some analysis, economic analysis, to see if in long term, if this is in your favor. One of the major steps in capacity planning is evaluating and assessing your current and existing capacity. There are some tricky aspects of capacity plan or evaluating your existing capacity that we're going to talk about it here. It's called, the major one is called the bottleneck operation. This means that basically, if you want to evaluate the capacity of your system, you're going to have a set of different operations that either work in parallel or work sequentially. So the bottleneck operation states that the capacity of your system is the smallest capacity, the lower capacity in your the operation that is in the sequence. That's going to dictate and restrict your capacity. So you can actually imagine this as a bottle that the amount of output, that means the capacity of output capacity for that bottle, is dictated by the narrow neck of that bottle. So as you see here, this is the neck of the bottle, which has the smallest capacity, right? The output capacity. So the whole system, the whole bottle output, whether it's any liquid is in it, if you imagine, it's going to be dictated by this neck here. This is going to dictate the capacity output for this bottle. So this is similarly true for other types of system. If you have a set of operations that work in sequence, as you see here, this is in sequence and these four are in parallel. So depending on whether if this was actually the capacity of this sequence, this operation right here in a sequence was smaller, then this is going to dictate the capacity of your system. So we're gonna see examples of this in the next slide. So this is the example, bottleneck analysis and average throughput rate. So in this system that you see here, we have three operations: operation 1, operation 2, and operation 3. These three operations work in sequence. Because they work in sequence, that means that the bottleneck operation for in this system that is going to dictate the capacity of the whole system is the operation that has the smallest capacity. So the first operation has actually an output of 20 items per hour. So it means that in a 1 hour, it can process 20 items. So we know this value. The second operation, the output is 10 per hour. So this is smaller than the first operation. That means that whether it doesn't matter how efficient or how productive the first operation is, the output of the first operation is going to go to the second operation and it has to process here. And then after its process, is going to go to the third operation. So that's why it's called bottleneck here, because no matter the before operation or the after operation, whatever is in this sequence that has the smallest capacity, it's going to be your bottleneck. So far we figured out that our bottleneck is operation 2 with an output of 2. So output of 10 per hour. Let's go to the third operation. The third operation has an output of 15 per hour. The out of these three, 20 per hour, 10 per hour, and 15 per hour. The smallest one is 10 per hour. So this is going to be our bottleneck operation, and it's going to decide the maximum output of the system. The maximum output of the system is equal to the capacity of the bottleneck. So the whole system is going to be, the capacity of the whole system is going to be 10 per hour, equal to the bottleneck capacity. So when you do an assessment of your existing capacity, you have to be careful about the bottleneck operation, because those are the operation that's going to dictate and restrict the capacity of the whole system. You may want to actually increase those capacity. So that means that it doesn't actually matter if I, for example, increase the capacity of operation 1. If I increase it in double, that means that instead of 20 per hour, it produces 40 per hour. Still, the capacity of the whole system is going to be 10 per hour because of the operation 2 is the bottleneck. So if I, for example, increase the capacity of the bottleneck instead of 10 per hour, if I double it to 20 per hour, then the bottleneck is going to be 15 per hour. So the capacity of the whole system is going to be 15 instead of 10.